Hi everyone. This 505 Manhattan campus lecture is going to give you the video lecture. Before I give you lecture, uh, here's a special announcement. Semester is around the corner right now. So the final exam is planned. I am proposing in this way. So I'll give you three different time options, similar to the midterm. So you practice already once. So this exam will be open Monday during this time, our lecture, or Tuesday afternoon and Wednesday afternoon, December 12th, 13th, and 14th. For the final exam, absolutely no makeup. Okay, so you have to plan it and then take the exam. If you expect any things, then you need to let me know early. If you are in emergency on this specific time, then you need to provide the excuse note. It could be a medical issue, um, yeah, something like that. So legal document needs to be filed to me. In that case, I will give you an incomplete grade, and then you may be able to get the regular grade during winter break. Okay. Okay, let's get to our operating systems. The last week I gave you a demo uh, in three different versions. When I look up when I yeah check the number of the viewers, actually not many students watched those. Yeah, I think about 50% of you guys watched uh, the demo video clips, which is not really acceptable. Yeah, please uh, check out the demo so you may be able to learn how uh, the client server can be built and communicated within the same platform or across the platforms. Okay, so what is left? Operating systems and database systems. Today we will look at operating systems. Okay, and then next week I'll give you another online lecture, which is the concept of database systems. So today and the next week, you will receive a video lecture. And then my final lecture in this semester, that is the week of December 4th. Then I'll give you a demo of database. All right. And then following week, that is your final exam. Um, so anyway, we may be able to meet on Zoom at least once. All right. For database hands-on lab, I want you to download MySQL. MySQL. I believe that is let me show it to you what version it would be. So I want you to prepare that and install it. MySQL downloads. There are two different versions, right? Mac version and Windows versions. So you need to install MySQL. You can download it from www.mysql.com. Go there. I want you to download the community version. Here are my enterprise editions. Yeah, community MySQL community download. I believe this is it. Let me click this. MySQL community server. Then there are two different versions available, Mac OS or Microsoft Windows, or Linux as well. There are many different versions available, right? So you can download the proper ones. If there's ARM processor, then if you purchase it a recent product of Mac Pro, then probably that is ARM. The earlier version, maybe 2-3 years ago, then Intel processors. The Windows versions, that'll be much easier, right? If you click Microsoft Windows, then simply, yeah, you can download the zip files and install it. The activation of MySQL is a little different between Windows and Mac OS. So we'll get to that, right? I want you to try. Mac version is a little bit trickier than Windows version. Windows version, that's if you install it, then you can, yeah, when you install it, please keep in mind the path expression, the location where that MySQL community server is available. Okay. All right. So we'll talk about that a little. Yeah, when it comes to probably there is a second week of December, right? So we'll do that. Probably there's 3 weeks from today. Today and next week. Oh, 2 weeks from today. Today we were operating system. Next week, the concept of a database management system. And following week, we'll work on hands-on. Okay. So SQL expression will be learned. That'll be the last lecture. And following week, your final exam. All right. So operating systems. What I will do, make it this much bigger. All right. What is operating systems? Operating system is a collection of programs, okay? So that manages your computing power. It executes your program, or it executes the programs already installed about your system itself. We call that operating systems, okay? Operating system is nothing but program, nothing but like the Python program that you coded earlier in this semester. You practiced a lot, right? And operating systems aims to make the computer system convenient to use. So that operating systems, that each programs knows how to manipulate hardware. Okay, PC or Mac or Linux machines, they're all hardware. Hardware is not only the processor, memory, monitor, mouse, keyboard, but also network and also security issues. Okay, so each of those devices, external functionalities needs to be managed by your computer. The program that you may be able to implement is not at that level, at that low level, right? Your program is a very high level, so we call that application program. But under that application program, so many programs are running. Okay, so operating system is a resource allocator. Operating system is a control program. It manages all the resources: hardware, network, printer, external, internal. It decides between conflicting requests for efficient and fair resource use. Your computer needs to manage so many internal and external resources. Among those resources, there may be some conflict in request, conflict in executions, conflict in negotiations, communications. All those things needs to be managed and controlled by operating systems. Someone may ask you, all those the detailed massive programs needed to manage the hardware and network resources, then it should be loaded and it should run, right? Once operating system is loaded in memory, like this, operating systems once loaded in memory, then your CPU fetch the data. Hey, at particular time, hey, I need to do security management. At another time, hey, I want to do network communication. I want to do something. I want to print. My user wants to do print. Some of the interrupt from the keyboard, all such things. So a lot of communications of the internal and external devices and CPU and memory. Once operating systems stored in your storage, right? So when you turn on the system, then operating system comes and available here. Some of them can be here, so that there's some control programs that program may control among those management packages. That's what they do. Someone may ask you, let's say your computer is just hardware, just cold hardware, unless you turn it on. Okay, one point. Another point, as far as operating system is loaded, then everything can be managed by that operating system. At one end, there's a completely hardware. At another end, operating system is is available. Therefore, once the operating system is available, then we don't have to worry about, because the operating system handles all details, how to manage devices, how to communicate, how to interact with the users, all those things, right? Between hardware and then hardware with the operating system, there's a little bit gap. Who brings operating system here on memory and available and let operating system operate, executes? Who would do that at the very first time? Once the operating system comes here, then it is okay, because the operating system can do anything. But who could bring operating system up to this memory, and therefore some of those here on CPU, from that time it runs? That is a big issue, right? Maybe there's a small gap, but maybe there's a big gap. If there's nothing, then your hardware is just cold metal. Operating system is still on the storage. Who brings the operating system from storage electronically to memory and then to CPU? That is called the bootstrap program. Bootstrap program reside in not in RAM, but in ROM. See here, ROM and RAM. ROM or EPROM. ROM and EPROM, it is not ROM and RAM. ROM is not volatile, which means it's not erasable. Okay, anything on this memory, here memory, this is a RAM. So if there is no power, all gone, right? Empty. If there is a power, then somebody brings the operating systems, load into memory, therefore CPU can use something from the memory. Okay, but there is a firmware loaded on this ROM, read-only memory. Okay, read-only. Once written, it is not overridden. So there is a ROM. On this ROM, there is a firmware. That is called the bootstrap program. What is a bootstrap? I want you to think of a cowboy, Texan cowboy. Cowboy, there's long boots, right? So it's very hard to wear that long boots. So usually, on the top of that high boots, there is a small the strap. Okay, so the cowboy pulled that strap up. Therefore, the long boots can fits in your foot, right? For example, that is called bootstrap. So word bootstrap literally used on this program. So that program firmware stays on RAM. When your computer's power on, then what the first thing to do is that firmware is loaded. That firmware brings the operating system to load on memory. That is all what that is the only thing that bootstrap program can do. Once operating systems the program is loaded in the memory, and therefore CPU can use it, then that is operating system's power, right? But connected to that from metal hardware, cold hardware, than that bootstrap program can do. That's a bootstrap. Okay. Computer system usually general purpose process, a single general purpose. General purpose program. It has a multi-processors systems. Therefore, it could be recent days parallel execution possible. Doing that, throughput can be increased. It's much more highly scalable. Reliability increased. Okay. That is a general purpose computing power retains these days. It's a general purpose. That's what we are talking about right now, right? Operating systems. But these days, as so many other the equipments and devices become smart. Smart means it has a computing power and it has a communications. For example, the vehicle, Tesla. Tesla has a computing power, very, very powerful computing power. But it does not need to do the general purpose processor, right? It has its own, not general purpose processor, it has a special purpose processor needed. For example, the computers installed on Tesla does not need to do the communication to printer, right? It does not need to do the execution of any Python development and codings. It doesn't allow us to access anything in it. It does not need to sending out mail or receiving mails, right? But it has some other specific purpose. If you have a smart refrigerator, smart refrigerator does not need to do all those things that I just described. It does not need to take photos, which is apparently different from Tesla computers. Tesla computer needs to do a lot of image processing, but on your laptop, not much powerful image process needed. Your smart refrigerator does not need most of those I listed, right? So some of the external, other than the computers, computer itself, general purpose computers, laptops, many other entities still need a computing power similar to our laptops, but not exactly the same. That is because that entity has its own specific functions, specific goal. So it needs its own processors, right? Anyway, that is a trend. So ARM and Intel, two different processors. ARM is more like the specific purpose processors oriented. Intel general purpose. But anyway, here we have symmetric multiprocessing and asymmetric multiprocessing. Asymmetric multiprocessing means each processor is assigned uh, a, a specific the task. Symmetric multiprocessing is they're all the same ones. So symmetric, then there's a memory. The same memory may be used by multi-processor, multi-CPUs, right? Uh, dual core, same thing. This is a symmetric, typical CPU example, right? Or quad core design. They're all in the same way. But asymmetric, that is more, we'll talk about that a little later. And then operating systems has multi-programmings. So that is single user cannot keep CPU and I/O devices busy at all times. So operating systems needs to provide not to all the features not only to one single user but multiple users. So multiple user can execute its own programs, but the same computer needs to handle multiple each of those requests from different users. So multi-programming organizes jobs. So CPU always has one to execute. If there is a one CPU, then one execution at a time, but it needs to handle multiple programs anyway, right? Therefore, there is a time sharing mechanism is needed that is called multitasking. Here is one program after another program according to job scaling, scheduling, multitasking. There's some other interventions. Before one program start to execute, before it ends, another program starts. But think about one CPU, okay, one stream. But then that execution stops at some points, and meanwhile, another program comes on CPU and starts, and another program comes in. A lot of interventions. So response, each user has at least one program executing in memory. If several jobs are ready to run at the same time, then CPU scheduling also. If a processor doesn't fit in memory, swapping moves them in and out to run. A lot of swiping is needed as well. Swapping that happens in memory only, and also between memory and CPUs, right? Here there is a cache, a little bit of the memory, so stays here, brings here, and then there is some executions. While this is executes, in order to maximize the CPU time, another program comes. Then if this is time sharing, then a program stops here while another intervention. Then this program pushed out in here cache, and this runs. And again, at some other time, if that program is called back in again to continue to execute, that'll be fine. But this may wait longer and longer. So this cache may be full, then part of this cache is pushed back to this memory. This is another type of swappings. Similarly, the memory, this is also limited, and storage is relatively lot bigger. So part of this can be pushed it back to the storage. Only this memory holds something that may be needed by this CPU sooner. If anything expected to be called by CPU later, then it can be, we call that flush back to this storage. So we can, there's some controllers also. That controller fetch the data to load in memory, and something that is already done, no needed by CPU, or because of this overflow, we need some space for other instructions that may be immediately called by CPU. Then we need to swap it back. So fetching it and flushing, fetching, flushing, fetching, flushing. There is a swapping also. Between this cache and memory, that is also a similar kind of swappings. Memory layout, multi-programmed systems. Multi-program is one program that is nothing but job in operating systems. There is an operating system's instructions resides on the lower address of this memory. Higher address, some jobs. Okay, a lot of details also needed, but in macroscopic, the memory may be allocated in that way. Operating systems usually runs based upon interrupt. So interrupt handling is very, very important. Why? Because your software, your hardware, your software may not know whether there is a email comes into your systems, whether there is a the HTML data comes into your web browser. So every time something happens, then hardware interrupts it. One typical interrupt from your hardware is from your keyboard, right? There's a Control C. Usually, Control C is an interrupt. So stop the current process. That is Control C. That's one of typical interrupt, right? Hardware interrupted by one of the devices. From keyboard, that is typical interrupt from keyboard is a Control C. Typical interrupt from the Ethernet connections, then there is some, if data comes in, then there is a little higher the current, the amplifier becomes higher than normal. Therefore, that tick into your network card. So network card, when it comes into network card, then network card interrupt to the operating systems. So that is a software interrupt. Some of the exceptions. Okay. As you do programs, because of the time issue, we will not do much about exception handling. But exception handling is another big issue, right? Python has an exception handler available. Exceptions are organized hierarchically. Part of the exceptions are already provided by your Python. Plus, depending upon your business logic, you may be able to define your own exceptions. As you define your exceptions, it should be defined along that exception hierarchies. So So that is exception handlings. If there is some error, some expected or unexpected errors, then you need to handle it on your program. That is exception handling. Suppose your program try to download Wall Street stock price. That is a streaming data. So you want to receive the data and the display and do some analyze. So that is the whole scenario of your Python programs. But what if there is no data comes in, but your program still some other steps in certain sequence, that steps needs to handle the stock data, but stock data does not come in, then you have to handle it, right? There may be two cases where data available, or if data is not available, then you can say, hey, there is an exception. So separately, that exception needs to be handled. So all such things may be interrupt-driven. The mechanism, therefore, hardware and software can be interacted with no big the problem occurring in between. In operating systems, usually there are dual mode, user mode and kernel mode. User mode and kernel mode. User mode so that you can enjoy a lot of things by yourself. Kernel mode, that sits there's a two tier. Above, that is user mode. Below, real low level, then there's a kernel mode. So kernel mode needs usually higher privileges. All the system calls goes into the kernel mode. Kernel mode cannot be accessed by regular users. Although some of the job needs to be done by kernel mode, although the job itself is just regular user mode applications. But there may be some cases it goes down all the way down to the kernel mode. For example, some of the network communications, some of the hardware interactions, all those things needs to be done by kernel mode. Without kernel mode, user application programs cannot do, right? But developer and users of that applications do not have the kernel mode highest privileges internally, so the privileges may be escalated. While the privilege is escalated, there may be some hackers tap into that escalations. Then hacker can have kernel mode the highest privileges. Therefore, your system can be compromised fully, in that case, fully, completely. But anyway, that is a side stories. Increasingly, CPUs support multi-mode operating systems. So now, virtual machine, VM, is also the current the paradigm. So as I said, the user mode and kernel mode, between those two modes, there's a transitions, right? some application programs in the user mode needs to do some of the actions in the kernel mode. Then there is a mode bit can be changed to 0 so that kernel mode, this requires highest privileges. So that is executed, and when it returns back to the application program, then that bit needs to be reset. Therefore, when it come here, then hey, your privilege is not anymore that highest privileges. That way, all those things can be handled. So timer to prevent infinite loop and process hogging resources. Timer is set to interrupt the computer after some time period. Keep a counter. There's some counting issues. Counter that is decremented by the physical clock. Operating system set the counter privileged instruction when the counter 0 generates an interrupt. Set up before scheduling process to regain control and terminate the program that exceeds allotted time. So there is a time checkings. So anything, it should not reside here longer, right? So these things is current techniques involved, but a longer time ago, there is no such things, counters and all those things, privilege issues. But anyway, that is. And virtualizations, this left-hand side, this is typical. We have one single sequence processing. We have hardware and kernel mode, and then on the user mode, there is an application is a processing. Therefore, we call that processes. Multi-process is handling here. If we have virtualization, then based upon the same hardware, we have a virtual machine manager. Therefore, there is a virtual machine 1, virtual machine 2, virtual machine 3. So each one has a different kernel. This could be Linux kernel, this could be Mac OS kernel, this could be Windows kernels. So upon this kernel, there may be a user mode and then process. That's possible. So on one machine, all different kinds of platforms running. Here on one machine, all dedicated operating systems. Okay. This kind of operating system, the concepts can be also handled by Pythons. So some of the command that I listed here, if you want to see the current work directory, then you need to, by the way, you have to first import OS, and then get the CWD. If you want to change directory, then os.chdil. If you want to see what operating systems that you have, then os.name. If you want to make a directory, mkdir. If you want to change the file, then rename. If you want to delete it, remove. If you want to delete the directory itself, then remove dir. This all the commands running on for example, then import OS, and then os.name, then the POSIX, os.get CWD current work directory, then there is users/users/jun. A little more, and then environment variables, os dot a lot of the path expressions. CPU count. I can see how many CPUs. That's CPU. There's a count. There's a function. CPU counts. Oh, I have 10 CPU. Hallelujah. And then terminal size, get login, get PID. Yeah, I mean, while your program runs, if you want to see who is running your program, then you can get login, right? Where start get login. Then there is root. Right now, root. I have root privileges. And get environment. And then there is a system modules, OS module and system OS. OS is, there's a general OS. System is my current systems. So if you to import sys, then sys dot here okay, let's do path that you can see. This is two things that you could do. You can use OS module. On OS module, you can get env and path. Then you can get that, or in on OS module, you can do environment, right? Oops. Right. And hash info. Some of you know what the hash is. The size of a hash. If you want to see sys dot hash info, then the hash algorithm is SIP hash 24 that is used. Hash bits 64 bits. The width is 64. So size is 64. OS does not have the OS hash info is available on sys. Okay, but OS can kill some processor. If that processor does not move, then you can do OS kill. See what happens. There's US function kills. So probably you need to have some of if we have some of the processors listed. What is the current processor? What is the list? What is the processors? Process. That's the jobs. That's programs. What are the processes currently executing? And then you can kill some of those if you want, right? So if we have help, and then there is a OS kill, OS kill PID. So process ID is needed, right? But anyway, so we are not doing that much. Okay, this is somehow the concept of operating systems, and then part of the operating systems can be handled by your application programs if you need to do, right? That is what we looked at here using Pythons. All right, this is it for the operating systems.